Thank you so much. Okay. It's not showing me this record. Oh, there, look at that. Hello and welcome to the Spokane .NET Users Group. So glad you're here. It looks like we have some new faces, so that's really exciting. Hopefully you're seeing my screen. You should be in the REST, Rex, and Microservices meetup. Is that all shown there for you? Yes, sweet. All right. We have our first in, at least as long as I've been here, speaker who is not part of the meetup already. So everyone, please welcome Jeff. I'm super excited to hear his talk tonight. Hi.
I did join today, so you can't actually say that.
Oh, well,
But
it's official.
Perfect record still, then, I guess. Let's see. I just wanted to let you know that the Spokane .NET Users Group is part of the Spokane Tech Groups, our meetups. And we also have the Spokane DevOps meetup and the Spokane Python Users Group, which we just joined this week, actually. So these meetups are all sponsored by Intellitext so that they remain free to the users. When we're meeting in person, we usually meet at Intellitext and they provide drinks and snacks and things like that, hoping to be able to get back to doing that soon. Most likely in September is our goal, but I make no promises until we know how things are going at that time. Let's see, the upcoming user group meetups. The .NET User Group, which is the one you're here for, meets the second Tuesday of every month. Our next meetup will be June 8th, and it is really tiny font, but it's real-time IoT with .NET and Raspberry Pi. I don't think I see the speaker here, so if you want more information, you can go to the Spokane .NET User Group meetup for that and to register. We just, as I mentioned, joined with the Python User Group, and I know I saw Joseph in there. Joseph, do you want to tell a little bit about next week's meetup?
Yeah, so this is my first time hosting / organizing the Python User Group. Just became the organizer for it. And next Tuesday, we're going to talk about Fast API, Python API framework. So hope to see some people there.
And we'll put the link to the Python meetup in the chat later on tonight for those who maybe aren't already members. And it will also be online like this one. And then the DevOps group is also meeting next week. They meet the third Thursday of every other month, and it's going to be focused on containers. Phil Spokus is leading that one. He's led several of these meetups in the past, so I think some of you know him. This is just about Intellitext. You're welcome to follow them on social media. And again, generally, they're always hiring senior developers based in Spokane. And today, I would like Kevin, who is a senior software architect at Intellitext and also a Microsoft MVP. He was had met Jeff actually at a previous meetup he did in Portland, I believe. So I was hoping you could introduce Jeff to us, Kevin. You're muted, by the way.
I'm getting good at that. Welcome, everyone. As Aaron said, I had the privilege of meeting Jeff a little while back at a Portland user group. Since then, we've communicated back a few times. He is an awesome speaker. I've gone through and listened to several of his talks out on YouTube, some of his podcasts. He's the host of Software Engineering Radio. So if people haven't seen that, I think Jeff is probably going to plug that a little bit later for people who are unfamiliar with that. He's also a passionate guitar player. He was very happy to be able to get his guitars in the background. I know when we were setting up the cameras earlier, we had to make sure to not necessarily crop all of them out. So very much looking forward to the talk tonight. Jeff, it is all you. Take it away.
Thanks, Kevin.
Awesome. Thanks so much for having me here, everybody. I think I've been near Spokane. I don't think I've ever actually been to Spokane. I'm trying to get my screen sharing working here. Can you all see a dark gray screen with my face down in the bottom left corner?
Yes, I can.
And a beautiful standard strat hiding behind me. and maybe the small contour of a tailor with a tobacco burst front on. All right, anyway, I suck at drums, but I'm learning. Yeah, I've been to Seattle, I've been to Boise, I've been to Salt Lake. I haven't been to Spokane, but that might change because my daughter is going to school in California, and she is dating a young gentleman who wants to be a neurosurgeon and wants to go to medical school in, drumroll, Spokane. So who knows? We might actually end up visiting Spokane in the near future. But hey, we're not here to talk about travel in Spokane and where we are from and where we've been and where we haven't been. We're here to talk about something very important. We're here to talk about how, come on slides, don't fail me now, REST, microservices. Oh, wait, what? Okay. What's the problem with REST? We use it every day. What's the problem with microservices? I use them all the time and they're RESTful and they work fine. Do you really? Do they really? Well, that's what we're going to talk about tonight. So a little bit about me. I've been working as a software engineer for over 20 years and as a software architect for over a decade. I'm currently working as a senior software architect at Viewpoint Construction Software here in Portland, Oregon. We were acquired a few years ago by Trimble. And so that Trimble's a really big company globally. They have about half of that, 12,500 employees globally. And my family just moved here to Portland in November of 2019. So that's a little bit about us. I also host Software Engineering Radio, which I'll talk a little bit about more later as we're talking together. About 10 other people around the world that are a part of that as well on seradio.net. And my latest publications can be found on my website, which I'll share as well later in the presentation. But if you're interested, tinyurl.com/dropagile was my most recent publication for the Cutter Business Journal, and it's titled, "Don't Disrupt Agile, Drop It." And if you haven't noticed yet, I have a proclivity to choose provocative titles for my presentations. So tonight, why the title REST Microservices? Well, first, no one is doing REST, and there is no such thing as microservices. What? Well, there's my beautiful family. Now that you're like, what? Anyway, there's my beautiful family, my wife, my 3 kids. Yes, you're shocked that I have a 21-year-old, a 19-year-old, and a 17-year-old. You look so young, Jeff, but the gray is kind of a dead giveaway. And my slides are being weird, but hey, here we go. So what are our goals for this evening? What do we want to cover? Well, I'd say this is the #1 goal. You want to avoid the pit of despair. Don't even think about trying to escape. Well, okay, here we actually are going to think about trying to escape the pit of despair. And of course, we also want to avoid the cliffs of insanity. But first, let's talk about the pit of despair. Do you know the pit I mean? It's the pit where software developers' eyes glaze over at the sheer technological overload and the complexity of the systems that they build and manage. I love what Neil Ford said. Developers are drawn to complexity like moths to a flame, and often with the same outcome. He wrote that in a book that he titled The Productive Programmer. How about you? Are you drawn to complexity? How do you know? And when you find yourself there, if you're lucky, you just end up mostly dead. And at that point, all you can do is run git blame on your repositories and see what you've left the rest of us to deal with as you move on to the next project. So perhaps when you experience complexity, you don't find yourself physically dead, but dead on the inside, resigned to a fate of coupling and complexity from which there is little hope of escape. Have you been there? The other goal is we need to learn to think for ourselves. I challenge you to never stop learning. Never stop challenging the conventional wisdom or what you think you know. Don't settle for what a vendor sells you or what a colleague tells you. Keep validating what you hear. It's amazing how often some of the most intelligent people in the world can fall into the trap of not thinking for themselves. Probably the smartest man who ever lived, Sir Isaac Newton, no, not Einstein, although he's incredibly brilliant. Sir Isaac Newton was incredibly brilliant, wrote Principia Mathematica, one of the most profound works of mathematics in all of human history, and yet he believed in something called alchemy, that we could turn lead into gold if we just found the right, the right magic incantation or the right whatever. He bought into that. what happens? Well, we can buy into bad thinking patterns. We can buy into ways of just thinking what everyone thinks and trying to fulfill what everybody wants. But sometimes what everybody wants isn't what's feasible, or isn't what's good, or isn't what's helpful. Now, ironically enough, now that we've entered the nuclear age, we know that alchemy actually is possible. It just takes a whole lot of energy, and it comes around from physics, not from magic. So you need to think for yourself. So tonight, I mostly don't want to give you answers. More than anything, I want to get you asking questions. And I'd love to continue the conversation after our time together this evening. So if you're going to talk about REST and microservices, there's a few names that you should know. Has anybody here heard of the name Roy Fielding? I'm not asking for questions. This isn't a classroom. If you haven't, it's probably good. If you're talking about REST or RESTful microservices or Swagger APIs with get, put, post, delete, probably a good idea to know who Roy Fielding is. Maybe the name Peter Rogers is another name that you should know. Maybe the name Yuval Lowy is another name that you should know. And maybe the name Michael Monty Montgomery is another name you should know. Maybe you're familiar with some of those, maybe you're not. Good names to look up, good people to know. Both practitioners and theoreticians have a lot to say, and we have a lot that we can learn from them about REST and about microservices and why REST wrecks microservices. So tonight I want to welcome our illustrious tour guide, Inigo Montoya, who says, REST and microservices, you keep using those words. I do not think you mean. I do not think they mean what you think they mean. Now, I have it on good authority that there is some history at the Spokane .NET User Group with Princess Bride references. I will say that I had the Princess Bride references before I knew that that was something that was common here at the Spokane .NET User Group. So it was a match made in heaven, okay? I just already was doing the Princess Bride thing, and you guys were already doing the Princess Bride thing, so here we go. So Inigo Montoya will be our guide this evening as we navigate the stormy waters of software systems. I think the first lesson to learn from Inigo Montoya is this: meaning matters. If you're going to use words, it might be good to know what they actually mean. So let's talk about REST. I spent some time a while back trying to get to the root of where did REST come from? What does REST actually mean? And what are we trying to accomplish when we create RESTful microservices? So I tried to find a helpful summary from this URL. This is the original dissertation from Roy Fielding on the idea of REST. And I could not find a helpful summary within Roy's dissertation paper. And if you know anything about highly technical and academic publications, they're not often known for their helpful summaries. But it's interesting. Take a look. Roy Fielding published his thesis in 2008. That's 13 years ago. In computer terms, that's aeons ago, right? It's the Mesozoic era or the Jurassic era. It was a very, very long time ago. And something a lot of people miss is that Roy was not being prescriptive when he described REST. He was being descriptive. If you're not familiar with the difference, to be prescriptive is to tell you what you should do. To be descriptive is to say, this is what is happening. Many people have taken REST and RESTful and Roy Fielding's thesis and have written treatise after treatise of prescriptive language telling us how we should do REST, how we must do REST, what it means to do REST. And ironically, at the basis of it all is Roy Fielding's thesis, which does not prescribe for us how to do REST, but instead it describes to us what REST actually means. So I encourage you to read it, and I encourage you to draw your own conclusions. Now, maybe you've never heard of Roy Fielding. Maybe you've never heard of something called Hate OS. Now, that doesn't mean you hate your operating system. I know all you Windows people, Hate OS is a daily thing for you, right? I'm a Mac guy, although I'm a .NET guy too. Hate OS doesn't mean you hate your operating system. Hate OS stands for Hypertext as the engine of application state. And if you say you're doing REST and you are not doing hypertext as the engine of application state, then you are not doing REST. You're not. People can put little things like RESTful. They can say, well, we use get, put, post, delete, whatever. But if you're not doing Hate OS, you're actually not doing REST. Interesting. So Roy Fielding wrote the paper on REST. He literally wrote the paper on it. There's the link, and you can go check it out. Now, later on, I'll share a summary document with the hosts from tonight with a summary of all the links from this presentation. So if you're sitting there typing https://www and you're getting a 404 error because you didn't type it in right, it's okay. We'll get you the slide deck. We'll get you the links. You'll be fine. Don't take my word for it. Go read what Roy Fielding had to say. And you will see that most of us are not really doing what he described as REST. Now, here's an interesting tweet from Roy Fielding. Someone tweeted at one point, they said, I agree the popular understanding of the term REST is different from the way Fielding described it in his thesis. Okay, so somebody says, everybody's arguing and this, and that, and the other, and someone says on Twitter, yes, I agree, the popular understanding is incorrect according to what Fielding actually said. And he replied with this. He said, I disagree that the popular understanding of the term is different. What is different is the desire of certain companies, authors, and speakers to say REST when they know it is just HTTP. Stop there for a minute. That's a profound statement. This is the man who literally invented the idea of representational state transfer. By the way, I didn't clarify that before. That's what REST means, representational state transfer. And he says that what really happened is vendors, companies, authors, people with a stake in making you think something you ought not to think, they had a vested interest in making you think that REST is just HTTP. Now, who uses HTTP here in their daily work? Anyone? Right? JSON with get, put, post, delete, maybe patch if you're super like amazing, and maybe know how to do options so that you can handle all your cores, headers, everything like that. Okay. Not because they don't know the meaning of the term, but because dollars, greater meaning. Roy Fielding. Don't take my word for it. There's the link to Twitter with Roy Fielding saying exactly this. Those aren't bit shift operators, by the way, okay? He's saying that dollars trump understanding, dollars trump meaning. When it comes to vendors, they don't care about the meaning. They care about the dollars. And so there's a lot of money to be made in confusion. And there's a question we should ask ourselves. Who benefits from confusion like this? Do we? Probably not. It's probably the vendors who are creating confusion and saying, you can create RESTful microservices if you just use our framework, use our tools, use all of these things. And we never stop to ask, did we need all these tools? Do we need all these things? Do we even want to be RESTful? Is HateOS even something we should aspire for? Roy Fielding was not prescribing you should do things this way. He was saying, this is how the web works. Interesting. So what exactly is REST? Another quote from Roy Fielding, again, in case you've forgotten, the godfather of REST. I am getting frustrated by the number of people calling any HTTP-based interface a REST API. Today's example is fill in the blank, okay? He redacted it. That's not me, that's him. Some company. And he says, that is RPC. It screams RPC. There is so much coupling on display that it should be given an X rating. If the engine of application state, pause, remember before I said HateOS, H-A-T-E-O-A-S, hypertext as the application of, hypertext is the engine of application state, okay? That's what he's talking about here. If the engine of application state, and hence the API, is not being driven by hypertext, then it cannot be RESTful and cannot be a REST API. What am I saying here? That I'm not telling you anything different than the person who created the idea of REST would also tell you. Who's doing REST? Almost no one. Who's actually doing REST? Honestly, it's basically web browsers. Web browsers are doing REST. Almost everybody else, not doing REST. So what exactly is REST? It's defined as an HTTP interface at its most basic. But it is, again, this idea that hypertext is the way that you represent the state of the system to another external system. Hypertext. What is hypertext? Well, HTML. Does anyone remember what HTML stands for? Hypertext Markup Language. If you are using JSON, you are not doing REST. Oh no, you're not. Hypertext as the engine of application state, that is REST, meaning the state of the application is represented through hypertext. The hypertext gives you the opportunity to click on links that take you to other places that allow you to create other actions or perform other behaviors that then present back to you hypertext. Now, is this always a good thing? Is this how every app should be built? You decide. I'm not here to tell you what to think. I'm here to help explore the space. But you're not doing REST unless you're using hypertext. Here's another misnomer. A lot of people think that get, put, post, delete equals CRUD. Hopefully you're all familiar with the acronym CRUD, create, read, update, delete. Of course, that didn't match the order, right? Get is not same as create, but you get the idea, right? Get is a read, put is a insert, get is a read, put is a create, nope, yep, I got it wrong. Post is a create, put is an update, and delete is a delete. That's what people think, but there's a difference. There's certain rules about REST. For example, is anyone familiar with the concept of idempotency? If you're not, it's a good word to look up. When you do an update on a SQL database doing CRUD, that does not mean the same thing necessarily as doing a put to a REST interface. The reason is that a put by definition means that if you give it the exact same payload, that it will result in the exact same outcome, meaning nothing about the system will change given the same thing twice. You cannot say the same about an update to a SQL database. For example, if the update includes a update modified by timestamp, nope, not idempotent, therefore put is not the same. So things to know. Does it matter? It depends. Sometimes it matters a lot. Sometimes it doesn't really matter. But why do we feel this need to label what we build REST? What's going on? Why do we want to do that? What's really the primary concern about REST? You see it right here. So much coupling on display. The primary concern that we should have is to avoid strong coupling between services. Roy Fielding observed the web back in the first decade of this millennium, and he observed that there was sometimes good decoupling between different parts of the system, different parts of the network. And he said that systems that are overly coupled are not what we want. Now he's being a bit more prescriptive. Systems that we want are not as coupled, and systems that are dangerous or difficult are the systems that are more coupled. But it does depend. And then again, when we talk about the engine of application state, so think about the applications that you build and think about how much of the backend system leaks out sometimes to client applications. So many applications that developers have built for the last 30 years have been basically what you'd call forms over data. Here's a screen, enter some data, hit save. Somebody else might have also tried to edit at the same time, and now we have race conditions, and is it last in wins? Are we gonna do optimistic concurrency? We have all these things to figure out. But then, now what do? We go run a report. And then we do it again. We enter data, we run a report. We enter data, we run a report. What this does is it puts everything related with dealing with the workflows of the system on the end user. The end user becomes irreplaceable. They require a lot of training. And if they go, they take all the tacit knowledge with them of which button to push, which form to fill out, which report to run, which thing to print, which thing to go do the next report. Hypertext as the engine of application state was meant to say, let's bring all of that complexity and all of that knowledge back into the system. Let's reduce the burden of complexity on the end user, and let's increase the burden of complexity back on the system. Here's a real world example. Why is your car easy to drive? Now, I know you go down the road and you see some people and you're like, well, driving sure doesn't seem easy for that guy. I mean, he just cut me off. But generally speaking, why is driving a car easy to drive? Is it because all the complexity is right there in front of you every time you're trying to drive? Absolutely not. Where's all the complexity in your automobile? It's hidden behind a very simple interface. And it really consists of about 5 or 6 simple parts, simple pieces: steering wheel, seat, accelerator, brake, maybe a parking brake, and a shifter. That's really all you need. I mean, yeah, you need an odometer to know how fast you're going, but you can drive without it. May not be wise, but you can. Okay, so driving is narrowed down to this very, very simple interface. Now imagine you're trying to drive a car, and instead what you have to do is you have to control the fuel injection timing while you're going down the road. You have to control the compression pressure on the braking system. You have to control the catalytic converter to make sure that it properly converts exhaust so that it comes out to meet the emissions of the state that you live in. You have to. This is very often how applications are built. If you've ever built a web front end that is very chatty and tries to coordinate multiple API calls to multiple backend endpoints, that is basically the car that you're driving. What Roy was saying 13 years ago was take all that complexity, and instead of putting it right in front of the driver, right in front of the end user's face, we want to take that complexity and we want to allow the system to give the user an improved experience, a simpler experience. We're not getting rid of complexity, but what we're doing is we're containing it. And I have another talk, if you're interested, on containing complexity that I can link to later. You can contain it, but you can't get rid of it. But what you want to do is take it away from the front-end user. Take it away from the front-end developer. By the way, side note, I don't know about your company, but most companies I've ever consulted for or worked for, they tend to hire their least experienced engineers for the front end, not their most. And ironically, then they offer them CRUD APIs and say, build me an app, and all of this orchestration logic and all of this complexity goes in the front-end application. So Roy was telling us something important. He was telling us that we need to get the application state into the system and not just spew it all about to all these people all over the place. But most people doing REST, what do they expose? Or saying they do REST, what do they expose? They give you create, read, update, delete. Here's an entity, here's a path, here's an ID, shove it here. When it changes, shove it here again. When you want to delete it here, and that's what you get. And then you have endpoint, 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 endpoint. You have front ends trying to coordinate all together, and it's a nightmare. Why do apps get harder to change over time? Why does the velocity of your team slow over time? Why do things get more instead of less complex over time? This is why. I'm sure you've been with the coder, maybe you've been the coder who likes to code using GitHub Gists or CodePen or our old standby Code Project. Anybody remember Code Project? You can get yourself in a lot of trouble by just copy pasting and making your code. So, all right. Question. Are you RESTful? Are you doing REST? We're asking the wrong question. Man, I remember this back. Maybe some of you remember back in the mid 2000s, people all over, did we even have Twitter 16 years ago? I can't remember, but all over wherever the social media flavor of the month was back then, fighting about that's not RESTful and that's not this, that, it's the wrong question. The real question you should be asking is, what's orange on your screen right now? How are we dealing with coupling? How are we dealing with application state? That's what really, really, really matters, is how you manage application state. There's a gentleman that you should know. Most of you have probably heard the name von Neumann or Dijkstra or Feynman. Very common names in our industry. The name that you have not heard, and shame on you, and me, because I didn't know him for a long time either, is David Parnass, P-A-R-N-A-S. David Parnass. When it comes to encapsulating the application state, David Parnass literally, okay, I kid you not, literally invented the idea. It's called encapsulation. You've heard of it. If you're a CS major, you took classes on encapsulation that did not teach you how to do encapsulation. Seriously, they didn't. If you haven't read what David Parnass has written about encapsulation, you probably don't understand encapsulation. In fact, when he first created the idea, Edgar Dijkstra thought it was crazy and said, nobody builds software that way. I think it was him. Don't quote me on it, but I'm pretty sure it was him. There was definitely someone well-known who said almost those exact words. Nobody builds software that way. Wait, but encapsulation is what we should all do. And yet, almost nobody knows exactly what it is and what it entails. Encapsulation does not mean private fields behind public properties. Nope. Getters are evil. Read Alan Holub. Getters are evil. What? Well, then what do we do without getters? Well, you got to read about it. Encapsulation is about not just hiding the data. It's about hiding other things like the sequence of operation steps in an algorithm. That's encapsulation too. And there's more to it. So how do you manage application state? Are you familiar with Parnass? Are you familiar with fielding? Are you familiar with encapsulation and what it truly means? Oh, and side note on that as well. When encapsulation was first embraced, there were actually people calling it Parnass encapsulation, but they stopped at Dave Parnass's request. And I told him recently, I said, Dave, that was one of the worst things you could have done, because if you had kept your name on it, people might have used it and known what it was, and they might have come and asked you. But instead, nobody knows who Dave Parnass is, and nobody knows what encapsulation is. So you owe it to yourself. Find out. In fact, side note here, one of the best books you can grab for yourself is this right here, Software Fundamentals by David L. Parnass. David Lord Parnass. I don't get any money if you buy this book. Okay, but Dave's amazing. Okay, so how you manage application state. That's what matters. Remember the car analogy. All that engine state, fuel pumps, carburetors, spark plugs, fans. If the user has to know about all of that, you are not managing your car application state very well. And yet most software applications that are running today just throw all of that right either in front of the front-end developer or, even worse, right in front of the end user. Let's talk a little bit about HateOS, a little bit more. So again, I mentioned before, if you haven't heard of Roy Fielding and HateOS, you're really not doing REST. If hypertext isn't your representation of application state, not REST. Hypermedia, remember, it is not JSON, it's hypertext. Okay. Now, let's read what it says here, according to Wikipedia on HateOS. With HateOS, a client interacts with a network application whose application servers provide information dynamically through hypermedia. A REST client needs little to no prior knowledge about how to interact with an application or server beyond a generic understanding of hypermedia. The restrictions imposed by HateOS decouple client and server. This enables them to functionally evolve independently. I'm sorry, this enables server functionality. Sorry, my head was in the way of my own slide there. Never mind. I thought I had my head not blocking any slides, but I missed one. Okay, so again, let's look at the orange. The restrictions imposed by HateOS do what? Remember, should we be doing REST? Should we be doing HateOS? It's the wrong question. What was Roy Fielding really trying to tell us? Well, before, you saw it on this slide. We should be avoiding coupling between services, and we should be making sure that we deal with our application state in an encapsulated fashion. Now he's saying we need to decouple client and server so that the server functionality can evolve independently. And I love some things about that paragraph in the middle. It talks about having little to no prior knowledge about how these things interact. Are you starting to see how really web browsers are the only thing that operate this way? Have you ever built an application that works this way, where the front end is literally driven by the back end and it can't do anything until it gets information from the back end? And then it renders a page based on what it's given from the back end, and then you interact with it, and there's more interactions with the back end that give you new screens or new things like this. And yes, we have spa apps, but still, oftentimes, we're letting the system handle application state, which is a good thing. How many client applications really know how to interact with an API like this? Not many. Something else to know about HateOS, it requires a single point of entry. All you know about is the entry point to the application. You go to blah, 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 .myrestfulapi.com, bam, here's everything you need to know in that payload to navigate to everything you can do from there on. Now, this might sound complicated, and it is. And this is why, typically speaking, the only applications that really follow HateOS are browsers and browser applications. So JSON APIs, they're not REST. Now, you might get Roy to give you a pass if you have a single entry point that gives you a list from your JSON of all the places you can navigate and all the things you can do, and action links and next page links and all these things all from a single thing. That sounds like a lot of work. Maybe it's worth it. Is it good? Is it bad? It depends. I just want you to ask, Do we really need to be doing REST? Does it really matter? Are we fighting for the right thing? And hopefully you're seeing that here, it's not so much about REST, it's about things that are more important. It's about encapsulation. It's about decoupling. It's about allowing services to evolve independently. That to me sounds like the holy grail of well-architected systems. So there's troubles with REST, okay? At least as it's commonly done. First off, despite the promise, you often end up coupled to technologies. It's very, very common. REST uses HTTP. That's a technology. You end up coupled to it. REST is not the fastest protocol. I'm sorry, not REST. HTTP, rather, is not the fastest protocol. And rendering everything as JSON is not always the fastest protocol. And calling all of your services over REST JSON, you're going to have some issues at times. I've seen microservices architecture where every single microservice communicates using REST, even when those services aren't exposed to anybody publicly over the internet. Is that a good idea or a bad idea? Well, again, it depends, but I would say that many times it's a bad idea, because if you're not exposing those to anybody outside of the internet, why don't you use a faster protocol? Why don't you, someone's going to say, well, Yagni, you don't need performance right now. I'm here to tell you, performance is a feature. Your users will never complain about too much performance, ever. They will definitely complain about not enough performance. Maybe we shouldn't be using REST for every microservice to talk to every microservice. Despite the promise, another thing happens. You end up coupled to tools and tooling. SwaggerGen, yay, we can SwaggerGen all of our REST APIs and everybody's happy. But now you're coupling yourself to Swagger. I hear more and more developers lately saying, why do we keep using ORMs? Why do we keep doing that when in some applications, it's so much simpler to just write the SQL and put the migrations in a SQL file and run them when you run your containers and you ship them and you just go and everybody's happy. Why do we go through all this pain? I think the same thing applies here. We get coupled to these tools. Look what SwaggerGen gives us. Look at the amazing things it gives us. And then we're stuck. Why do we even need these tools? Now, there's no silver bullet. I'm not here to tell you that gRPC will save your life and make everything wonderful. I am here to say, maybe you should consider it. Maybe SwaggerGen isn't the end all be all. Maybe there's a place for it and a time for it, but maybe it shouldn't be the only way that your microservices expose their APIs to each other. Despite the promise of REST, you often end up coupled to transports and protocols, which, HTTP right there, you're stuck. That's what you've got. Also, despite the promise, you often end up with business logic right at the edge where the only concern should be plumbing and not logic. I remember back in 2006, back in the days when Microsoft was still the evil empire, even though many of us were still doing evil empire things. And there was a small group within Microsoft that started creating something called ASP.NET MVC. Anybody there in those days? I was working at a company and we used the beta 1 of this. And I was pretty green in my career, still learning a lot of these things. And we had a lot of questions. Where does the business logic go for these applications? Does it go in the controller? Does it go in a method? Does it go in the database? Where does it go? Where do we put our business logic? And so often I've seen over and over and over again systems where you hit and by the way, ASP.NET MVC core, same issue. Controller. You hit a route, you hit a controller action, and then what do you see? Pages and pages and pages and pages of logic right there in the controller. Question. Should a controller be concerned with more than routing you to the right action? Or should it also be concerned with performing the action? You can probably guess what I think the answer is based on the way I phrase the sentence. Controllers should be a way to get the right request to the right responder, but the response should not be right there in the controller. Otherwise, what are you doing? You are coupling yourselves. You're coupling yourself to ASP.NET MVC and the HTTP protocols that it provides. So with all of these things, we couple ourselves to tools, to technologies, tooling, to transports, to protocols, and now we end up with huge coupling between our clients and the APIs we publish. I mentioned it before, but it bears repeating. Client applications that are calling multiple endpoints and trying to orchestrate them together, there's a name for these in the industry. They're called mashups. That's a terrible name. And I don't have a good name for them, okay? They're massive, chaotic messes of disaster. Because front-end applications that try to orchestrate calls between multiple back-end systems are doomed to fail. You're going to have performance problems. You're going to have complexity problems. Nobody's going to know what's going on. I'll give you an example. On a recent project that I worked on that I came to green, I hadn't worked on it before, but the project, I came in to work with the team. I discovered a place where a single page to render was calling 3 dozen API endpoints in order to pull the data together to present this page. This I call endpoint proliferation. And what's worse is to perform a certain business process that took, say, 18 steps, right? 12.5 steps. If something went wrong along the way, the client application then had to perform either reversal logic or retry logic in the front-end application. And when something went wrong, it was almost impossible to debug and almost impossible to fix. How many applications have you worked on that's exactly what they do? Orchestration logic is in the front end, and you can hardly call it logic. It's an orchestration spaghetti mess. So the other issue with endpoint proliferation is that changes on the back end require changes on the front end and vice versa, almost always. And you get these chatty conversations where the front end is constantly banging on the back end to figure out what's going on. And your apps get slow, they get hard to debug, they get hard to maintain, they get super, super, super complex. Reliance on complicated tooling really doesn't help either. Okay, you're just basically shifting the complexity around, but it's not really making things simpler. That's why things like SwaggerGen, they can be great for a well-designed API, but they will not save you from a shoddy, poorly designed API. They just can't. So is any of this REST's fault? Not necessarily, but I'll say this. Unthinking adoption of any approach will lead to pain. Even if you adopt the most beautiful, wonderful, amazing approach that's ever been created to designing software systems, if you don't know what you're doing, it will still lead to pain because you won't do it well. Most of us aren't dealing with the end all be all, this is the best way of doing things, and we just don't know what we're doing. Most of us are dealing with, have I really thought about whether this is the best way? Have I really thought about whether this meets the needs of my customer, of the business, of the team that I work with? I mean, I could do a whole talk on the team maturity model, where certain teams just aren't ready to adopt certain approaches and certain technologies, and you have to deal with that, and you still have to deliver. But that's a whole topic for another time. Now, in biology, we get evolutionary signals. When something is wrong, when something is broken, what happens? Natural selection says, you're out, right? Remember the Darwin Awards, kind of offensive, but also strangely kind of funny in a sad, pathetic, interesting, the train is crashing, I can't stop watching kind of a way. But we don't get these evolutionary signals a lot of times in software. We just say, well, we're doing Agile and we're pulling stories off the Kanban board and we're delivering value early and often. And yet, let's be honest, how often does the emperor really have no clothes? And we're just pushing. The developers are stressed, the project managers are stressed, the product owners are shrugging their shoulders. They don't know what's going on. And yet we have the evolutionary signals. We just often are prone to ignore them and use excuses like we're doing REST, we're doing Agile, we're doing what everybody else does. But I want to encourage you, think for yourself. Think for yourself. Let me give you an example of how things used to be and then how they became and why I still have hope for the future. Back in those early days that I mentioned, back in 2006, when ASP.NET MVC Beta 1 came out with Hanselman and Hack and Connery and a few other guys that were basically turning Microsoft into the Microsoft we now have, which is the open source Microsoft that we hope plays nice forever. We don't really know, but we're rooting for it, right? We're like, okay, come on, Microsoft. Back in those days, if you wanted to test your controllers and your actions, they had mocked out the HTTP context with something called HTTP context base. Now, if you've ever looked at the old HTTP context before, oh, wow. I mean, there's so many dot this and dot that, and like you can go 5 layers deep on this thing and find all kinds of stuff there. And they managed to put it behind an abstraction called HTTP context base. Now, that was a monumental effort, and kudos to them, congratulations. But then somebody got the idea and they said, why are we trying to abstract away this thing? Maybe we're doing it wrong. Maybe there's a simpler abstraction of the web that we could deal with that would make it easier for us to build applications that are less complex, that are easier to understand, easier to extend. And so some people got the idea to create something called Owen, the Open Web Interface for .NET. And the first versions of Owen were just that. They were very much coupled to Owen, or I'm sorry, to .NET. Of course, they were coupled to Owen because it was Owen, but they were coupled to .NET. But what they did is they distilled a web request and response down to the bare bones, smallest possible number of components. And it basically turned out to be just iDictionary of string, comma, object. Again and again and again and again. Like that's pretty much all it was. And then they made it so it wasn't just .NET specific. They basically said, we can distill the web down to this very, very simple, powerful interface. And suddenly, what do we have now? Do you remember the days of IIS? I know some of you are still using it, and that's okay. But there's a new web server on the block from the Microsoft land, and what is it called? Kestrel. Kestrel is a child of Owen. If you worked with Kestrel and you've worked with ASP.NET over the last decade, you've realized you've gotten much, much closer to the metal. Remember the web forms days where Microsoft wanted you to pretend that your applications were just web wind forms running over the web, and you started using state, and state got unwieldy and it got nasty? Because a lot of times a bad abstraction makes you think things aren't complex, and it's really not helping you. But once we got down to the metal and down to the wire, it opened up a whole new field of possibilities where things became simpler because we understood what was going on under the covers, and we had a powerful abstraction there. The irony about Owen, it has nothing to do with REST. Nothing. Nothing to do with RESTful. Nothing. It's just getting down to the nuts and bolts of what is a request, what is a response in a HTTP conversation between a client and a server. So here's our friend Inigo Montoya again, reminding us to think about the words we use and what they mean. So, should you REST? It depends. Is HTTP the right protocol for the situation at hand? In certain cases, absolutely. Yeah, I still use HTTP. Now, I do something different. I'll usually use what's called an API gateway pattern. And the services that are being exposed are, if they're running in process, they're behind interfaces, controllers receive requests, translate them into messages that are then passed down to the service via the interface. If there's a need for scale out horizontally, those services will go over some protocol that is not HTTP in order to reach the service. It's probably going to be gRPC. If hyper performance is needed, we might even drop down to domain sockets and just do socket IO. Sometimes you need that level of performance. But when you use REST for everything, you remove those options from yourself. So is HTTP the right protocol? Look, when we're exposing our systems to external users, which also are front-end developers, because come on, if you're a back-end engineer, front-end developers are outside, as well as API integrators, third parties, things of that nature. Yes, in those cases, HTTP can be wonderful. What about hate OS? Will the benefits of hate OS outweigh the complexities and difficulties of implementation? It's a good question. I'm actually exploring this right now. For a long time, I've had this sense of this principle that I rarely see implemented in the industry. And the principle is this: front ends should only be smart about how to render. They should not be smart about what to render. That sounds kind of like what I think of when I think of hate OS. Now, this is challenging, and I get that it's challenging, but let's think about the benefits for a minute. If a front-end application has to be smart about what to render, you've already gotten yourself into the point where it's going to have to make multiple calls to multiple endpoints in order to coordinate and pull things together in order to present an experience to a user. And if any one of those things changes, the whole interaction becomes suspect. It can fall apart just like that. So what if instead, and it's challenging, okay, but what if instead we said the backend system is smart about what is going to be rendered for the user at a certain point in time? The front end is only smart about how to present that to the end user. Now, this doesn't preclude things like WebSockets or SignalR for the backend being able to say, hey, this portion of what you should be rendering changed. I'm updating it. Now, please change the how you're rendering to match the what you should be rendering. That's fine. But think about the power now. You can have components in a front end that know how to render particular kinds of payloads coming from the backend system. And you can say a payload with this schema goes with a component of this type. If you need to version it, then you say, we're versioning this, make us a new component. Is it backward compatible? Sure, fine. Then you plug the new what into the old how, and you just don't see everything. Is it not compatible or there's new things you need to expose? That's fine too. Make the next version of the component that works with that version of the what. Now you have a new what and a new how, and you go rinse, repeat down the way, okay? This could eventually lead to doing hate OS, except that it won't be hypertext. But the idea is that application state would be encapsulated in the system, not encapsulated in the front-end application. If you know anything about distributed systems, stateful, stateful, stateful is always going to kill you, and stateless, stateless, stateless is always going to win. So imagine stateless front ends with stateless services that talk to, at the very bottom, stateful stores, like a SQL Server or a Kafka queue or a Redis cache, but everything else in between is stateless, including almost the front end. There's a lot of power potential there. Final question about REST. Could there be problems adopting common approaches that you find with a quick Google search? Yes. Yes. Google is not the end all be all. And hopefully we all know that, but we don't always behave accordingly. All right, so should you worry about REST, whether you're doing it or not? Yeah. It depends. Sorry to be a consultant again. It does depend. I would say more often than not, no, don't worry about it. What you should be worrying about is loose coupling and independently evolving services. And you're never going to get there with tight coupling, chatty interactions with front ends trying to orchestrate huge, massive, complex use cases across multiple endpoints. So let's stop for a second. Any questions so far? Or comments or tomatoes you want to throw? Come on, unmute those mics. So we're all tracking.
So I'll throw one at you, Jeff. The description of what you were just describing with the idea that the front end, I want to make sure I don't say this incorrectly, where the front end is knowledgeable on how to render, not necessarily on what to render.
Yeah.
Right. That it almost sounds a little bit almost parroting back to what you said at the beginning about how only web browsers are effectively doing REST, right? That feels very much akin to that pattern where my browser doesn't know much. It only knows how to render hypertext, right? And the server is just putting it out. And is that a fair comparison to say that effectively almost what you're positing is a browser style architecture within the browser? Not to word it too poorly.
I'm not sure I follow the last part. I think the earlier part, to some extent, yes. I think in the earlier days of the web, and we all remember these days if we've been around for more than 15 years. Do you remember those days where we did something called server-side rendering? Right? Before SPAs and all of this stuff? I have a question for you. Have SPAs really saved you? Have they really made things less complex and easier to manage? Really? Really? Anybody upgrade from Angular 2 to 4? Anybody from 4 to, what are we on now, 11? God help you. Especially 2 to 4, that was the death one, but still. So yeah, it's interesting how the old things can kind of reveal to you things. And I'm not saying we should go back to all server-side rendering, by the way, but you should be aware of this very important thing. When you go to websites that are the most highly trafficked websites in the world, what they almost invariably do is they give you a cache-based server-side rendered version of the page. They shove that up to you real quick, and then they use sockets to start filling in the gaps. Almost invariably. Why? Because when you let state be in the backend system, it's less complex and you get more performance. In a similar fashion, could we do something similar with our Xamarin apps, our Flutter apps, our, you name it, right? Fill in the gap, your other kind of app. Sure we can. Sure we can. People are afraid, like, wait, but everything should be in the front end. Again, I say, if your company is anything like the ones I've worked for, companies tend to not hire their most senior developers for the front end. And when you do that and you put all that complexity in their hands, you're going to get a very, very difficult situation. So I don't have all the answers yet, Kevin, but I can say that I definitely am convinced it's the right way to go. To say that front ends should get, and by the way, this isn't purism, right? This isn't saying front ends can only do how and back ends can only do what. I'd say it's more of a trajectory. This is a trajectory that we ought to move in, where we would say over time, our front end should be less and less concerned with what to render and more concerned with how, and our backend system should be more and more concerned with what to render instead of just saying, here's some CRUD endpoints, knock yourself out. Does that help?
It does. And you made a comment there that I want to just point out a little further, because you had commented on Xamarin apps as well. And initially I'd been thinking of this only in the web space, and it's very interesting to think of it with much more of a thick client approach rather than just a web-based approach.
It is, and someday I'll do a talk on this, although in the interest of time, we probably can't go this far now because I haven't even talked about microservices yet, but we will in a second. Mobile app, I will tell you the Zen of mobile applications. You ready? This was hard fought. The Zen of mobile applications, because first off, let me set the context here. I hope you all realize the fallacies of distributed computing. And one of them is the network is reliable. That's a fallacy. If you are doing a mobile application, you have got to embrace the fact that your application is partially connected, whether you like it or not. Now, the simplest apps to build in the world are the ones who can trust the fact that the network is reliable, which back in the days of everything running on the same LAN, on your corporate network, it was still a fallacy, but you could get away with it. You could pretend it wasn't true. If the network is down, you went and you got a soda or you took a coffee break, you came back and everything was fine. But now you get distributed computing and we can't trust that anymore. If you are building a mobile application, it is a partially connected application, whether you like it or not. And the simplest apps to build in the world are the ones that trust the network is reliable. The second simplest ones are called batch applications. They connect, they get everything they need to build their context, they go offline, they do all of their work, they come back, they reconnect, and they batch forward everything back to where it came from. That's the next difficulty, so very simple. The hardest one is the partially connected app. Am I connected? Am I not? When did I disconnect? What did I have when I disconnected? Can I perform this use case or not when I'm disconnected? Those are incredibly difficult to build. And here's the Zen of those kind of applications. The application is always connected. The application is never connected. I know, it sounds contradictory. If you've ever read The Hitchhiker's Guide to the Galaxy, it was very important that Arthur Dent learn how to have both tea and no tea at the same time. Actually, you know what? That may just be from the Infocom game. I can't remember if that's in the book. Somebody can help me hopefully with that later. But in the Infocom game, if you've ever played Zork, Hitchhiker's Guide, the old text-based games, I know I'm dating myself, really fun. Anyway, he had to find a way to have tea and no tea at the same time. If you want to know the Zen of partially connected applications, they are always connected and never connected. Now, let me explain what I mean when I say that. There's this huge trend called backends or front ends, and almost nobody knows what they're doing. And I hate saying that. Like, it sounds arrogant or but honestly, they don't really know what they're doing. Backends for front ends should embrace this principle of the front end is never connected, the front end or the application is always connected, the application never connected. And here's the general gist of how you do that. You need to have some way for the back end to represent state. You're probably going to have some kind of event sourcing, some kind of feed state where you can say the state of the backend system has changed this step, this step, this step, this step. And every time you do that, you're keeping a change log. Think of it like git commits, hash, 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 hash. If the front end goes offline and then it comes back online, it can say, this is the last hash I have of that feed. And then the back end says, here's the hashes you've missed, grab them. It brings them up. Now you need to have the same replay logic on the back end that you have on the front end that says, given these, this is how Git works. Given these commits, if I apply them in order, I will result in the exact same end state that creates the exact same commit on both sides of the same Shea hash, right? On both sides of the wire. Now what you can do is you can say on my front end mobile application, I have a back end process that's running and it is managing network connectivity and disconnectivity. The front end application is only and always pretending it's connected, but it's only talking to a local data store. So now what's happening is this backend store is saying, here's my latest commits, system, Tell me if anything's changed since my latest commit. Yes, it has. Here it is. It's going to replay that locally to update state. Send a message through some eventing system, whether it's a little mini message bus in your mobile app or whatever it might be. Say, hey, this state has changed, refresh. If your current front end presented page doesn't care, you drop the message, you move on. Because next time you open a page, you'll go fetch the state from the local store and you'll present it. If it does care, you just say, refresh the page with the latest data from the local projections that were made off of those commits, boom, and you're good.
Hey, Jeff, Mike was asking about e-tags.
Yep, that's another way you can do it as well. Yeah, lots of ways to handle this. E-tags, like I said, they can work. Sometimes they're complicated, depending on like lots of factors. I've used it before. They kind of, they're not strictly coupled to REST or HTTP, although that's often where you find them. But yeah, there's absolutely nothing wrong with using e-tags in that regard as well. I think one of the big things that I like about using checksums is the idea of content address storage, meaning the payload defines the ID. And there's some huge benefits to doing content address storage instead of location-based storage. And depending on the way you do your e-tags, you can still avoid being location dependent in your identities. Whole nother topic for another day, but yeah, great point. Any other questions of that? Did you kind of get the Zen? Always connected, never connected? It's just about who's always connected and who's always disconnected. Literally built an app that way at a company I co-founded, and it was out in the field in an ag farm, in an agriculture environment, and it worked. It was offline. It did its thing. Now, if there was certain data missing, okay, but there was kind of like this mini batch thing you had to do in the morning to get everything I need to do my work. And then once you did that, if you were out of cell phone range or whatever, it didn't matter. The backend was handling, am I connected or am I not? And the front end was just dealing locally. And the same logic for saying, oh, I got this data, do this to it. Here's the transform function, then update accordingly. Worked on the front end, did the same thing as the back end. One last thought on that. This is how web applications should be built also. We need to stop having web applications that say, oh, here's a REST endpoint, I'm going to go get the data. No, 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 no. What you want instead is you want to be able to say, well, I have local storage now, and I have WebSockets now, and I have background worker now. It's not background worker. Somebody help me. Is it called background worker? There's a relatively recent thing on web browsers for doing background processing. Worker service. I think that's what it's called. Anyway, you can emulate the same thing on the web. Now you can have a web application that is always connected and never connected. By the way, this is how Google Docs works. When you say offline mode, it's exactly how it works. It's using something called conflict-free replicated data types, and you can go Google that yourself, and it's a whole huge rabbit hole, but it's amazing. And that's how Google does it. If you want to do it how the big boys do it and reduce complexity, I'll say this. To make a car simple to drive is a lot of work, but it's not a lot of work for the person who buys the car. To make applications like I'm describing is a lot of work, but it reduces the work for your end user, which I think makes it worth it. Okay, any other questions on REST before we move on to microservices? All right, I do want to point out, I know in the title slide, and Aaron, it's okay, I want to mention this so people know. The title is not REST, Rex, and microservices. The title is REST, Rex, microservices, meaning if you do REST, you're going to wreck your microservices. I will leave you to decide if I actually believe that or not, but it's a provocative title. All right, so let's talk about microservices. If you've been around microservices for a while, does anybody remember something called Corba? Yes, no, back in the Java days in the late 90s. How about COM? Did you realize if you're doing .NET, you're still doing COM? Yep. .NET Core? Yeah. .NET is basically COM under the covers. COM stands for Component Object Model. Corba and COM were technologies that tried to make it easy to call services provided by other applications, okay? Components that maybe I didn't create, but somebody would say, here's an interface, and if you call me, these are the kinds of exceptions I'll throw and the return types I'll throw and the messages I'll receive and process for you, and you could plug in and you could go to town. Now, COM was a mess in a lot of ways, But here's what got right. Classes with interfaces that encapsulate behavior and state. That's a very important sentence. Don't focus so much on classes. And when I say interfaces, don't think so much .NET interface. Think interface, like I said before, about a car. Steering wheel, shifter, seat, accelerator, brake. Okay, interface. What does it encapsulate? Behavior and state. That's important. Encapsulation is not just about state, it's also about behavior. If you can encapsulate the user from the behavior, now you can change the sequencing of operations without the user having to know it. You can change the algorithm. You can change state storage and retrieval. There's all kinds of things you can do. Now, a question on microservices. Can anyone tell me what a microservice is? You can unmute again. What's a microservice? Anybody remember Kids in the Hall? I crush your head, crush, crush, crush. Okay, again, dating myself. What's a microservice? Is it a teeny tiny service? Does anybody know what a microservice is? Please, someone.
Very quiet people. Kevin, you can talk. You don't have to just type. People are typing.
Well, I'll ask this. I'll say, are any of you building microservices? And if so, why aren't you answering and telling me what a microservice is? Because if you're building them and you don't know what they are, shame on you.
Does it count if you're building something called a microservice, but you aren't convinced it is?
Well, I think that's part of the problem, right? Okay. Near where I live up here on the Columbia River, we have a huge dam, more than one, and it has pumps in it. Then in my house, I have a water pump, and in my car, I have an even smaller pump. And then there's microflagella that have little pumps that they use to push out water so they can swim. Which one of those is a micropump?
Well, Mike just posted in the comments that microservice is a single unit of responsibility. Does that sound about right?
I'm looking for the comments because I don't see how to see them, and I want to see them. Ah, there we go. A service that is made by Microsoft. Thomas? No. Yeah, that's funny, but okay. Close. But here's the thing. I think the point is nobody really agrees on what a microservice is. So a single unit of responsibility, notice it's not about size. So that's why I'll say, okay, like I'll take that answer and go with it for a minute. It's a meaningless phrase in many ways, to be honest, because it's not about size, okay? But most people think microservices are about them being tiny. I mean, what's next? Nanoservices, picoservices, femtoservices, you know, we're gonna go down to, what's at the bottom? The smallest possible length of measurement is the Planck length. Okay, we're gonna have Planck services. Oh gosh. All right, where did microservices actually come from? They first came about with a gentleman named Peter Rogers, who was somebody who'd been in the Corba world and the SOAP world, and he was coming out against SOAP, which is Simple Object Access Protocol. And it is neither simple nor the rest, okay? He came out against it, and he proposed something that he called, and I love this, wait for it, REST services. Oh, Peter, you're so close. With a service able to call any other service. Now, was this good or bad? Any service able to call any other service. I do another talk called Software Architecture as Complexity Containment. I can tell you right now that if you have only 7 services in your network and you have no rules about how those can communicate with each other, there are 5,040 possible permutations and combinations of the ways those services can interact with each other. Should we have a system of 7 services with no rules about how those can communicate with each other? Can your team handle the complexity of not knowing which of those 5,040 possible interactions are currently in use and which might be in use tomorrow that nobody caught in that pull request that slipped through at 5 o'clock on a Friday? Heck no. Double it to 14. Anybody here have a microservices architecture with 14 services? We have 3 dozen where I work. If you have 14 microservices, and that's us microcosm, okay? That's the team I work on, and then it gets bigger. If you have 17 nodes in your network with no restrictions on your interactions between their 87 billion possible combinations, of the ways those services can interact with each other. That sounds like hell to me. Now, take those 7. Let's go back to 7 because 14 is like, it's going to kill us. Take those 7 and say, okay, but we're going to put in a restriction. A service that calls one service means that that one cannot call in the other direction. Anybody know what happens when you do this? You say A can call B, but B cannot call A, or depend on. I mean, of course it can respond, but A can call B, but B cannot call A. And when you do this all the way down your network, you get what's called a directed acyclic graph. When you do that, you reduce the number of possible combinations from 5,040 to about 21. That's good. Do we stop and say good enough? Nope. Now what you do is you introduce layering. You say, these are the services that these external parties can call. And if we have 7, let's say we expose 4. And then those 4 can interact with these 3 that the world does not see. When you do this, you bring the number down to 12 possible interactions, which is another 43% reduction in the possible interactions. And I would say it's worth it to get that extra almost 50% of complexity reduction. So was it good when Peter Rogers said, let's have REST services where any service can call any other service? No, it was terrible. And it's what you call now 16 years later, the state of the software industry. It's terrible. It's awful. So in 2005, a gentleman named Yuval Lowy was quoted as saying, every class should be a service. This sounds crazy. Every class is a service. Well, what's a service? What's a service, right? And here's what he said. I never called these services microservices. Then as now, I did not think the microservices concept existed. There are no microservices, only services. Now, some services are better than others. Some services you have an interface with a class that implements it, and that's the end of it. Okay, it's still a service. Is it a good service? It depends. Depends on the context. Depends what you're doing. Maybe you create a decorator around it, and you had login and security around it. And then if anybody asks for the I blah, 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 blah service, they get the they get the blah, blah, blah service decorator that wraps the blah, blah, blah service. Okay, we're getting a little better. Now logging is out of the implementation. It's wrapping it, right? Okay, we're starting to get there. But you can see, you can add these layers. But his point was, it wasn't microservices. It was that everything can be thought of as a service. Anything with an interface can be thought of as a service. It may be well implemented. It may be poorly implemented. It may be a well-defined interface. It may be a poorly defined interface, but they are still services. And this is why the concept of microservices is kind of ridiculous. Anything with an interface can be thought of as a service. The next question is to ask, does it encapsulate behavior? Does it encapsulate state? And can it evolve independently of the other services around it? If you do microservices the way that Peter Rogers described REST services, the answer is no. Because if every service can call any other service, you're never going to be able to have independently evolving microservices, which, by the way, I would add previously to Mike, who said a single unit of responsibility. Another hallmark that they say of microservices is independent evolvability. But most microservices architectures I've seen totally neglect that. They're not independently evolvable. And then finally, Michael Monty Montgomery, I don't remember the exact year, but he has a wonderful talk called The 10 Fallacies of Microservices. One day I need to say, Monty, please post this publicly on the internet. If you look around things like O'Reilly or other websites, sometimes they'll have seminars. And if his ever pops up, you owe it to yourself to go watch Monty do his 10 Fallacies of Microservices. It's a wonderful talk. But one of the takeaways from that is I was speaking with Monty relatively recently, and he showed me some new stuff out of Microsoft. And if you go to Microsoft's website and you search for something called the API Gateway Pattern, you can start to see what's wrong with microservices and also what could be done to possibly start making it right. Here we have a picture of a direct client to microservice communication architecture. You can probably tell by the picture that this is what I'm talking about when I say front ends orchestrating interactions between multiple microservices. So we've got the order service, we've got the customer service, we've got the shopping cart service, and the front end just dutifully stitches it all together. For a simple application, maybe you can get away with that. Most applications grow beyond that pretty quickly, and it becomes a nightmare. And yet what happens? We throw more resources at the front end, we expose more endpoints from the back end, we do crazy things like saying, well, here's an OData endpoint and you can just do whatever you want, or here's a GraphQL endpoint and we just unthinkingly let you do whatever you want with the data. By the way, nothing wrong with OData or GraphQL. What's wrong is using them without really thinking it through. So this is a nightmare. This is an integration nightmare right here. And really, it's worse. I mean, right? Let's be honest. This is what usually is actually happening here. And even worse is oftentimes the web app, mobile app can call any of those services on the right side as well. Like lucky you if you at least have some layering here to reduce the complexity a little bit. And then some developer comes along and he says, well, I want this microservice up here to talk to this one too. And they add that, and then, you know, it just, the complexity grows and grows and grows and grows and grows. Seriously, I mean, hopefully this is hitting home for some of you. I can't show you slides from where I work because it's proprietary, okay? But I saw a flow for a simple use case that involved an orchestration of 5 different microservices from a front-end application with over 40 steps. And if any of those steps failed, it was up to the front-end application to figure out what to do. So what does Microsoft start recommending? What's this? We have an API gateway. Interesting. I kind of referenced this before when I said REST isn't always bad, or I'm sorry, HTTP isn't always bad. Fine. Your SPA apps probably don't speak gRPC. Okay. Some of them don't even speak SignalR. Look, if you still have to support some old version of IE for a customer that's running Windows XP, yes, they still exist. Yes, not just overseas. This could be you. What an API gateway does, also known as the API Aggregator Pattern, is another way to look at it, is it aggregates together the ability to access these services that are behind it. So what do? Well, over here, you define these services the way I do it in terms of interfaces. Okay, so I have a service interface and I say, this is the behavior that this service will expose. And then I serve that up via maybe a gRPC API or whatever it might be, and I wrap that service in this backend here. So say anybody who wants to talk to this service has to come in through this protocol gateway. And this protocol is gRPC or it's domain sockets. Maybe it's even HTTP, but whatever. And then in this gateway, what you do is you say, here's my controller. Okay, fine. Let's go ahead and use ASP.NET Core. Let's do it. We make a controller, in comes a request. It's a job of that controller to say, well, for this request, this is the service that's going to get called. And that service is going to use a client that's going to say, okay, I take let's call this the order service. You're going to have an order service client. And that order service client is going to be used by this API gateway. And when it asks for one, all your configurations in your app settings, JSON, or in your cube control, or your Helm charts, or whatever it might be. But anyway, you get this client, and that wraps all the stuff from you of how you're actually communicating with the microservice, what the protocol is, and everything like that. Okay, it is RPC, and that's okay. RPC is not the bad, horrible thing you've been told that it is, especially inside your system, where services inside a Kubernetes cluster or app services running the same, subscription on the same Azure region. Fine, just let them talk RPC. Okay, save yourself a lot of trouble, a lot of pain. So that's the idea. You can ask me more about that later, but there you go. That's the general idea. And even here, you can have a backend forms over data. No, I'm sorry, not forms over data. Static rendered, right? Server-side rendered application that is also here running using the same API gateway. So it's an improvement, but there's still no organizing principles. Okay, we can still run into this mess, right? And this still has its own problems. And this is called backends or front ends. Not the way I would do it, but the way that most people do it. They create a different gateway for mobile and a different gateway for web. Sometimes this makes sense. More often than not, it's people just hand waving saying, I don't know what to do, and they just follow the pattern that they saw from Code Project or GitHub Gists, or in this case, Microsoft's architecture guidance. It's not best friends forever, it's backends for front ends. Actually, I want to say a little bit more about that. Okay. So in this case, the reason I'm not a super fan of this, here I'll go back so you can see what I'm talking about, kind of relates to something I said before. The future of applications are partially connected applications that receive updates to their state incrementally, that can operate in a disconnected fashion because they do not fall into the fallacy of distributed computing that the network is reliable. What this means is you really shouldn't have these different gateways for these things. If you did, it would maybe be because you want to limit the scope of what you send to a mobile versus a web. And then that's fine. But what you would do is you wouldn't let the topology of your deployment architecture determine that. In other words, the ability to serve up different data for mobile versus web should not require you to deploy 2 different ASP.NET Core services. Shouldn't require it. It's an option. It's a deployment option, but it shouldn't be the only way you do it. You should be able to host those together. You should be able to host them apart. You should be able to scale them independently of each other, these kinds of things. Okay, that's all I'm saying is don't just say, oh, I have 2 of these and this is how I do it. One's web, one's mobile. Stop, think about your use case, think about what your needs are, how you need to scale, what your cost constraints are, all these kinds of things. So that is microservices. So where do we go from here? Well, we want to avoid the pit of despair. And it is true that most people are hearing the albino saying, don't even think about trying to escape. And usually people's only escape is to find a new position somewhere else where they fall right back into a new pit of despair. How do we avoid the pit of despair? You think for yourself. You know, it's ironic. I wrote an article I mentioned before for the Cutter Business Journal. I think I mentioned it. You know, maybe it was before the talk. Never mind. I wrote an article for the Cutter Business Journal a few months back, and they were looking for papers to answer the question, does Agile need to be disrupted? And this is not the Agile talk, okay? This is REST, Rex microservices, but just to give you a little taste. And I submitted my paper, and my title was, Don't Disrupt Agile, Drop It. What? But we're doing Agile, everybody's Agile. Okay. One of the founders of the Agile movement about 7 years ago said Agile had run its course. And ironically, one of his primary reasons was because Agile had become a noun when it was meant to be an adjective. What's funny is I did not know, this is Dave Thomas, by the way, not Dave Thomas Wendy's, Dave Thomas Agile. I did not know that until I started writing my paper, and I drew the same conclusion, and then I went searching for evidence, and I found his paper, and I even referenced in the paper, like, dang it, like, I came up with the idea independently, or maybe I came across it 7 years ago and just forgot somewhere in the recesses of my brain. But I gave him credit and said he came up with the idea. And one of the things I noticed as I was doing my research as well is that if you go to agilemanifesto.org, I think that's where it is, there's a little link that says about the history of the manifesto. And if you go there, a very interesting thing happens. In fact, let's take a little trip down memory lane, and I will show you to what I refer. Oh, no. Somebody want to sell you on Agile? Oh, yeah. Okay, here we go. It is agilemanifesto.org. So hopefully you've all seen this before, or if you're lucky, you haven't. Okay. 12 principles. We follow these principles. Nope, that's not it. Somewhere there's a history. Ah, there it is, about the manifesto. Now here's one of my favorite things about this. You get to the bottom, and there's a very, very interesting sentence here from Jim Highsmith. We hope that our work together, see this right here? Hopefully you can see kind of where my mouse is going. We hope that our work together as the Agile Alliance helps others in our profession to think. To think. I cannot tell you in my over 20 years in this industry how many times I have seen people shut down all thinking by saying we're doing Agile, or we're doing Scrum, or we're doing XP, or we're unit testing, or we're delivering fast and often, or we're pulling stories off the Kanban board. Look, the people who created this said, we want you to think. Even they said that. And let's not forget that these were highly successful software engineers, not developers. There is a difference. And it would be like putting the Navy SEAL team together and saying, how do you organize and how do you operate? And then asking a brand new green team to operate the way the Navy SEALs operate. So why do I say it's time to move on? Well, that's one reason why. So the Agile Manifesto history writer, Jim Highsmith, would tell you, please think for yourself. Think for yourself. Don't even trust me. Go look at the source. Go read. Find out what's going to work for you and your customers and your team. freedom to think for yourself. And finally, keep asking questions. Keep learning, keep reading. I've noticed a lot of developers don't read as much as I think they probably need to. And you don't need to read a ton. I mean, I'm a huge reader, but you just need to read a little bit more than you are right now, just a little bit more. Read more about some of these things. Read more about how to get better at using your tooling, whether it's Visual Studio or VS Code. Learn how to get better at the shell. Learn how to get better building CI/CD pipelines with Azure DevOps, YAML pipelines, or GitHub Actions pipelines, right? Learn, read, do that stuff. And think for yourself. So, does REST really wreck microservices? The answer, you probably know now, after spending an hour and a half with me, is it depends. Although I would say usually it does. Usually it does, in my experience, and probably yours as well. You see, here's the problem. There are hundreds of ways to wreck a software system, but there are very few ways to get it right. Now, when we're in the early stages, of course, iterate, try, trial and error, that's fine. But at some point, you got to deliver. And when you get there, if you're still iterating on your design, you're dead. It's like saying, I want a house, I'm going to buy some land, and I'm going to hire the Agile construction team. And I'm going to throw a bunch of tools on the property, and I'm going to throw a bunch of construction workers on the property of all various tools or various capabilities. And I'm going to say, please self-organize yourselves to build me a house. And they're going to say, what are the requirements? And we're going to put together a Kanban board, and I'm going to start putting stories on the Kanban board, and I'm going to start saying, well, this is what I want first. And they're going to say, oh, okay, you want a bedroom first. And so they build me the Agile bedroom. And I say, well, I wanted the bedroom on the second floor. Oh, crap. And on and it goes, right? You see the problem, I hope. So stop chasing promises, terms, technologies. Look, you don't have to do what Roy Fielding says. But if I'm you and I say I'm doing REST, I want to know what it means. And there's an ego saying, don't use that word if you don't know what it means. So in the same way, figure out what it means. And if you don't need to know what it means, then just don't use the word. Say, this is what we're doing and here's why, and have a way to back it up. So REST wrecks microservices? Probably, because there are no microservices and no one's doing REST. Questions?
And feel free to turn off your mic or your mute, I guess, so that you can ask directly if you don't.
Yeah, turn off your mute, turn on your cameras. Let's have some fun. I want to hear from you guys.
There was one comment from Thomas in the chat, Jeff, if you wanted to provide any feedback on it.
Okay. Some people say Agile is too slow. Personally, as a developer, I want a slowly changing platform with long LTS. And I'm trying to remember what that means. I know what it means. Long-term support. Enter the industrial age of computing. Well, yes and no. So Thomas, I don't entirely disagree, but here's an issue. When we say industrial age of computing, it kind of in some ways harkens back to something called Taylorism. And I'm going to forget his first name, but there was a gentleman whose last name was Taylor. And in many ways, he was basically the father of industrial manufacturing. No one is going to argue that industrial manufacturing has been hugely successful for us as individuals and us in many of the industries in our world. However, the market gets more complex, the world gets more complex, the systems we build get more complex, and a Taylorist factory model will not serve us well anymore. It just won't. And that's where we have to start leapfrogging to what you might call anti-fragile architectures. There are small pockets of this that you're starting to see, but I still think we're a far way off from really getting there, but I think it's going to start happening over the next decade. If you've never heard the term anti-fragile before, think about this for a minute. What is the opposite of something that's fragile? Something that's fragile breaks very easily. Most people would say the opposite of fragile is robust, but that's not correct. Something that is robust, it's unlikely to break as easily as something that's fragile, but it is not anti-fragile. Something that is anti-fragile gets stronger under stressors. It gets better under stress to a certain limit. Your body is anti-fragile. You want to strengthen your bones? Break them a little bit. Why do boxers have such strong hands? Because they're constantly getting microfractures in their hands. You want to get strong muscles? Tear them a little bit. Don't overextend them, but tear them. Tear your muscles. Break your bones. You want to have a strong software system? Kill it. Take down an entire AWS computing region. Right? Now, that's flippant, okay? You should never just do that flippantly. But if you learn from the chaos engineers, you'll find that part of what they're doing is moving towards anti-fragile systems. Now, they can show you your system is not anti-fragile. They can't necessarily make it anti-fragile. But long story short, the industrial model is not going to serve us much more for very long. We have got to start thinking about how to build the next generations of systems, which is systems that gain from disorder and chaos, not just can accommodate it. And by the way, I would say that would be the heart of agility as an adjective, but not agile as some religious noun that the zealots want us to conform to.
I see Jack.
Hope that helps, Thomas. More to add on that, Thomas, or?
Thomas is actively typing, it looks like.
Okay.
Jack commented in between there, just time and motion computing. I don't know how that.
Might need to tell me a little bit more about that, Jack. Time and motion. We're talking about like time series databases. Are we talking about event sourcing or? Where's Jack?
Taylor timed everything.
Ah, thank you. Yes, which is not necessarily bad. That's how you get data and evidence for making your next theory for your next go round. That's right. And we can learn from Taylorism. I'm just saying we need to go even beyond Taylorism. But thank you, Jack, for that. I will say this. If you're not at least doing that, you're definitely not ready to move to anti-fragile. Timing and planning everything. It's ironic. A lot of Agile teams, and I say Agile with a big A, like the Scarlet A, you know, Hester Prynne. Okay, not the good A, the big bad, like big, you know, the big A Agile. We don't plan anything. That's big design up front. Or we just plan for the next sprint or whatever, blah, blah, blah. Okay. And here's the funniest part about it. In fact, I have a book back here, right here. This very large book right here by Baron von Clausewitz. And of course, now I'm forgetting if it was him or another German general who said this. I think it was von Clausewitz, but if it was not, please don't quote me on it. But there is a, hang on. Sorry, brain's catching up after talking for 90 minutes. Nope, it's not him. He does have a great quote, though. I'll get to in a second. Dwight Eisenhower said, "The plan is nothing, planning is everything." Okay, great quote. The von Clausewitz one escapes me right now. Oh, I know what it is. Ah, I remember now. Yay, von Clausewitz. So first, remember Eisenhower. Okay, planning is nothing, planning is everything. Von Clausewitz said, "No plan survives first contact with the enemy." Now, I've heard this used by Agilistas. Yes, I have an affectionate little pejorative nickname for them, to say, therefore, we don't plan. The irony, and I learned this from one of my mentors, who I mentioned before, Yuval Lowy. The irony is that what von Clausewitz meant was that you need dozens or hundreds of plans, because the first one you come with will not survive first contact with the enemy. So then what do? You bring in this plan based on that contingency, or this plan based on that. Or you say, well, plans B, C, and D, they're close, but now we need plan E that's a conglomeration of those. But if you didn't have those, you wouldn't have as quickly arrived at plan F, G, or H, right? So Taylor timed everything, and you should plan everything. If you don't want to do big design up front, here's the irony. You have to plan everything. It's the total opposite of what you're ever told. Whoa, big design up front, we don't plan. No, it's the other way around. If you want to avoid big design up front, you must plan everything. And you'll notice this more and more, by the way. When you choose to believe that everyone is doing it the worst possible way, whether it's true or not, just use it as a foil. Use it as a thinking tool. Although sadly, it's very often true. Everyone is doing it wrong. In fact, they're doing it the worst possible way. Again, something I learned from you all. When you start thinking that way, you will find creative options you never thought possible, and you will start to see the world in a very different way. And it will be very revealing to you along the lines of what I just showed you. So say the opposite. Oh, big design up front, we shouldn't plan. No, it's bad. In fact, it's the worst way. What's the opposite? Well, it could be we want to do big design up front, maybe, or it could be, as I'm proposing, no, we don't, but how do we avoid it? By planning more, planning the right way, at the right level of granularity.
It looks like we have Michael has his hand raised. I don't know if that's intentional or not, or Michelle, maybe. I'm not sure.
No, Michael, yeah. Thanks, yeah. My other computer didn't have a microphone, so I was typing away. But first of all, shout out from Fort Collins, Colorado, not Spokane. But
hey, Fort Collins, our home office for Trimble that I work for is in Westminster. So
there you go. Yeah.
Right up the road.
Our .NET user group died, so this was I got wind of this title from George Stocker, and it did not disappoint. So, anyways, and so basically, you know, to start out with, 100% agree with everything you've presented here and the pitfalls and so on. But I did want to nitpick a little bit. One was, and first of all, before I nitpick, you had asked about any front end that was driven by the true principles of REST, of state through hypertext. And I did want to give a little mention to a tool that Microsoft got right, and unfortunately for legal reasons they had to drop it, which seems pretty typical for Microsoft. But there used to be a tool called LightSwitch, and very few people ever used it or heard of it, and it was, you know, horrible interface and slow when the applications came out. But essentially it would scaffold up an OData service, and it was the early OData. But when the data would come back and forth for your data operations, it was a payload that had essentially links that were, you know, saying, okay, your next set of the object that you want to delete is at this URL. The object you want to find was created at this URL. The collection that's going to fill the next drop-down box is found at this URL. So it did it really well, and it really hit a good design principle that unfortunately was some patent troll came and they had to take it off the market. Anyways, I just want to throw that out, not a big discussion, but I did want to nitpick a little bit.
Real quick?
Sure, yeah.
I would say that because I remember it, and I love how in here somewhere it says it's a new. Oh, here it is. LightSwitch is a new product in the Visual Studio family. It's new, August 2011. I remember this, and I remember because I had just recovered from being a Microsoft Access over SQL Server developer and thinking I could do everything with stored procedures and VBA. And I had recovered a lot longer ago than that, but I was still having to support maintain apps that I had built in the late 90s and was like, ugh. So you're right that you could quickly get an app going with LightSwitch, but it struggled with the same problem as something like Microsoft Access. The complexity was not really contained and encapsulated properly, so it would not scale.
Oh,
so,
absolutely.
Yeah. So just like Access, like if a business developer gives you a proof of concept and says, this is what I want to do, awesome tool for that. Yeah. Or simple flows that aren't going to change often, totally agree. So
No, agreed. No, it was horrible. It was painful to work with, but it had that little, nice little shimmer of hope of saying, this is how you drive the front end. Anyways, to get back to the nitpicking part, and that is, what I have seen from other presenters that were very much, promoting the hate OS and the principles and saying you're not doing right if you don't have the hypertext driven. However, they still presented it as you could have a JSON payload as long as the JSON payload contained those, basically hypertext links to essentially, here's my for operations, my for CRUD operations, or collections or next data. And so, I was just wondering when you were talking about if it's not hypertext, it's not REST and JSON isn't REST, but I don't know, is there room to be a little softer on that if you pursue that pattern of getting the links as driving the state rather than user knowledge?
Well, Michael, I'm going to give you my favorite answer, and you already know what it is.
It depends.
Okay. I would even say it's a different question. Does it matter? And I'm not belittling your question. It's actually a great question, but does it really matter? Here's the trouble with most of those APIs. And this is a fundamental problem in our industry. Too many of our APIs are glorified data access layers. I'm going to say it again. too many of our APIs are glorified data access layers. And what happens is that leaves complex orchestration logic up to someone else. And I'm a big fan of the principle that we should do hard things and do when Robert Downey Jr. was getting his life back together after a massive destruction of his life through drugs and womanizing, whatever other crazy shit he did. And a guy named Mel Gibson, who is still universally reviled, went to him and said, if you want to get your life back together, you need to hug the cactus. And he did, and look at the result. I mean, I'm a huge Marvel fan. Watching Falcon and Winter Soldier with my boys, so much fun. Like, I can't wait for Loki. Okay, totally awesome. And Jon Favreau, God bless that guy. Marvel and Star Wars, he rescued along with Dave Filoni, God bless him. So anyway, that's a bit of a tangent. So why did I go there? Because you got to hug the cactus. The problem when you expose your services as just basically crud services is you are not hugging the cactus. You are making everybody else suffer. And a good professional embraces the cactus, owns the suffering, and makes things easier for everybody else. And that's where we desperately need in our industry to, and I'll go pretty hardcore here and say you should never, ever, 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 never expose that kind of thing to a front-end developer or to an API integrator. What you should expose is services that drive a use case and perform a workflow. And they perform the steps in the sequence of operations or control the steps so that the front end or the API client does not have to concern themselves with those things. And if it needs to say, go get data there and come back when you're done, it says, go there, do this thing, and either there's a webhook that'll automatically call it back so the user doesn't have to do it, or it'll get a payload that says, now go here instead, and it'll continue from there however you want to build the API. That is where it needs to go. And I think, and you probably, I see you nodding, like you probably had that in mind. And maybe that's what some of these people are promoting. And if so, I think that's great. But to the extent that we just give people an order service that has entity framework behind it and ships OData, it's death. You're not
agreed 100%. Yeah. No, I don't even use ORMs, but, and sure, I think maybe my question was, my question was hiding the fact that I wouldn't necessarily want to expose that as the interface, but it would be a layer, right? It would essentially, if you were to translate, like you said, your data layer into services, then you might have a middle layer that's orchestrating, but that middle layer would say, hey, okay, if those services come to me with this sort of hypertext driven or link driven action and direction and self-describing flow, anyway, so I was just asking, do we have to denigrate the REST just because it's JSON so much and doesn't have HTML? Yeah.
I agree. I mean, I pushed pretty hard this time on it's hypertext, and it's not JSON. Of course, HateOS, it says hypermedia. So again, the term
exactly.
You see there, and so when I expose an orchestration service, because I don't expose access layers, and I don't expose algorithmic engines, I expose orchestrators. Do I expose those via an API aggregator that lets the client use REST? Yeah. And JSON? Yeah. Do I say it's, I'm sorry, I didn't mean to say REST. I totally had a Freudian slip there. Do I use HTTP? Yes. Do I use JSON? Yes. Do I gripe and complain or moan or tell everybody it's REST? No. Is it RESTful? I don't care. That's my point.
Sure.
This book will help you understand how to design systems. Some of what I'm describing, it won't give you everything, because the author wants you to take classes and trainings and learn. And that's also because you can't learn everything you need to know from a book. And there's another book I'll recommend after this one, but I highly recommend this book because it will help you to think in layers like you're describing, Michael. And it gives you a method for saying, these are the layers in my system, okay? These are my clients, this is my orchestration layer, these are my stateless algorithms, these are my stateful accesses to stateful services, and here's how I build my system together so that I can conceive of, how to solve the business problem. Excellent book, highly, highly recommend it. I will also say that another one that is worth your time. In fact, for this one, I'll link you here. Whoa, that's a big face. This is an episode I did on the art of immutable architecture with a gentleman named Michael Perry. And it was for a podcast on which I'm a host called Software Engineering Radio. This is another great one to look at as well. When we talk about distributed systems and scale, it's really important that we start learning to embrace immutability. And please listen to the podcast. I think it's a great episode. Of course, I'm biased because I was the host, but Michael's a wonderful guest, really smart guy. Basically has taken the math of Feynman and a bunch of other luminaries and has converted it into an approach for us to build systems where it's not so much that the architecture itself is immutable, because that sounds terrifying, but that it's the data within it is immutable. And getting nodes in a network to be able to agree on what it means for the data to be immutable opens up all kinds of options for us. So when we think about moving past rest, or again, using it as a way to transmit, these immutable bits of state around, fine, but it may not be the best protocol. Kind of opens up some options. So definitely encourage you, take a look, if you will, at Writing Software by Yuval Lowy. Take a look at The Art of Immutable Architecture. And I believe he is also at, nope.
Hey, Jeff, Jack is asking if the Portland user group recorded his talk. Did he recently speak there?
He did. Thank you. Yeah, if you're not familiar with the PADNUG, which no longer stands for Portland Area.NET User Group.
Oh, really?
It doesn't. No, it is the Portland Microsoft Developers Group now, but it's called PADNUG because legacy. So go to meetup.com/PADNUG/ I can't talk anymore. It's been a long day. And if you scroll down to see all, oh, look, there's me. If you'd like to see my talk on software architecture as complexity containment, I recommend you check it out. And I also recommend you check out somewhere down here. Oh, Damola's great. You've got to check out Damola Omoshota. Hanselman, who's that guy? Oh, come on. I was just teasing everybody. Anyway, somewhere in here is Michael's episode. There's this thing called Google. Oh, you know what? I might have linked to it from my website. Aha! Well, I still linked to my site, but I will paste it here. And if you click on that link, you will get a nice little YouTube link that pops up, and you can watch Michael Perry talking about immutable architecture. Yeah, thanks whoever brought that up. Good stuff. And as we wrap it up, if you want to find me, well, I'm pretty easy to find. JeffDoolittle.com/GitHub, LinkedIn, Stack Overflow, Twitter, Facebook, Instagram, YouTube, SoundCloud. And I think the Facebook doesn't work anymore because I quit Facebook. I got tired of the politics and it's just a mess. I think the Instagram doesn't work anymore either, but who wants to follow me on those things? I'm definitely on GitHub. I'm definitely on LinkedIn, definitely on Stack Overflow. I'm only a few million points short of John Skeet. Come on, people. Like, just go plus up my Stack Overflow. Anyway, never mind. Yeah. And then my stupid head is in the way, but this is my Don't Disrupt Agile Drop It article, which you will either enjoy because you agree, or you'll either enjoy because I'm a heretic that needs to rot in hell forever. But one way or another, you will enjoy the read.
Nice. And we did go ahead and throw some of those links in the comments as well, including the link to your post there and to the Software Engineering Radio. Thank you so much, Jeff, for volunteering and tracking us down and coming to speak. I'm sure I speak for everyone here that it was really enjoyable, and we hope to have you back at some point if you're up for that.
Yeah, absolutely. Maybe next time I'll show some code.
Ooh, look at that.
But yeah, and maybe sometime I can actually come in person if this whole pandemic thing, kind of goes the way we hope it goes. So really appreciate it, everybody. Thanks for having me.
Great. And for everyone else, if anyone would like to speak like Jeff is, feel free to email me or post in the comments, and we'll hopefully see you next week at the Python group.
Awesome.
Thanks, everybody.
Thanks a lot. Thank you.
See you next time.
Thanks.